Mockney 52. In the circuit shown in the figure, reading of voltmeter V1 when only S1 is closed is V1. Voltmeter is V1 when S1 is closed. Reading of the voltmeter is V2 when S2 is closed. And reading of the voltmeter is V3 when S3, S1, S2 both are closed. Then you have to find the correct relationship. Sixer and voltmeter is connected between these two. Okay. So this is S1, this is S2. When only S1 is connected, S2 is open, then voltmeter shows reading V1. We can find V1s. When this one is closed, this one closed means resistance of the circuit is R plus 3R, that is 4R. Okay. Then we can write in this first case, current flowing to the battery is I. In that case, I can write E equal to I1 into R plus 3R, because R and 3R are in series. When S2 is open, S1 closed, these two are in series. Okay. Then from this we can write I1 equal to E by 4R. I1 equal to E by 4R. So the voltmeter reading V1 will be 3R into I1, because voltmeter in that case will measure the voltage across 3R resistance. So 3R into I1, that will be 3E by 4. 3E by 4. I substitute the value of I1, that is E by 4R. So R will cancel, it will be 3E by 4. Okay. Now, in the second case, let us consider the current flowing through the circuit is I2. When S2 is closed, S1 is open. In that case, E should be equal to some I2 into equivalent resistance. In that case, R and 6R are connected in series. Now, so I can find I2, that will be equal to E by 7R. E by 7R. So potential difference measured by the voltmeter V2 is 6R into I2. So that is 6E by 7R. This is the voltage measured by the voltmeter now. Okay. Now when S1 and S2
will be cancelled by 16.
Oh. 6E by 7. Now when S1, S2 both close, reading is V3. That means now the current flowing is say I3, then E will be equal to I3 into equivalent resistance. What is the equivalent resistance? 3R, 6R. Equivalent is 2R. 2R plus R, that is 3R. So now I3 will be E by 3R. Now the reading of the voltmeter in this case will be V3 equal to this I3 multiplied by equivalent resistance of these two, that is 2R. So R cancels, it will be 2E by 3. Now compare. So in three cases you have to find out V1, V2, V3. Then you have to check which option is correct. So remember that this voltmeter is connected across this resistance in parallel combination, that is 3R and 6R. So when S1 closed, S2 open, means this resistance is inactive. So you have only two resistors, R and 3R, and they are connected in series. So their equivalent is 4R. Then accordingly find current I, and then find the potential difference across that 3R, because voltmeter is connected across this line. Okay. First case. So in the first case, this is closed. In the second case, S1 open, S2 closed. So that's why the total resistance will become R plus 6R. R plus 6R, calculate I2, and then calculate the voltage across 6R. That is measured by voltmeter. In the last case, S1, S2 both closed. So close both. In that case, what will happen? These two are in parallel, and that is in series with R. So see 3R, 6R, parallel will be 2R. It is in series with R. That is total resistance is 3R. Then calculate I3 and calculate V3. Now which one is option, which of the option is correct? Option C. How? How option C is correct? Three, 7, 4. Take their LCM, multiply, and denominator will be equal, and then compare. 3, 7 and 4. 3, 4 and 7. What is the LCM? 84. 84 is the LCM. LCM of 3, 4, 7. Okay, that is 84. Now calculate. This one is multiply this one with 28 by 28. Multiply this one with 21 by 21. Multiply this one with 12 by 12. All the denominators will become 84. Then which one will be highest? Then you can compare and find the answer. Essentially I multiply all the term by 1. but 1 is written in that format. 28 by 28, 21 by 21, 12 by 12. So this one is V3 is coming 56 E by 84. Okay, this is V3. V1 is coming 63 E by 84, and this one is coming 72 E by 84. So 56, 63, 72. So V3 is, V2 is highest. V2 is highest, then V1, then V3. V2, V1, V3. Option B is correct. V2 greater than V1 greater than V3. Okay. How you said option C? Question number 47, the circuit shown in the figure. Figure is not there. Then, at the midpoint along the length of a solenoid, the magnetic field is equal to X. Okay, that question. See, we know that inside the core of a solenoid, magnetic field B equal to mu naught N by L into I. N by L into I. Now, length is doubled. Now we can say that entire length of the wire L, that is equal to N times 2 pi r, because each turn has a radius r, so it will occupy a length of 2 pi r circumference. The total length of the wire is N times 2 pi r. N turns are there. Now I can say that if you change the length like this R will not change. R will not change because radius of the solenoid will remain same, because the wire is wound around a insulating cylinder and that cylinder's radius will not vary. So this N by L ratio is 1 by 2 pi r, that remain constant. Since R is not changing, then N by L ratio will remain constant. Means if L is doubled, N is also doubled. Okay. So that means when current is half, magnetic field will be half. Current is set half, na? Reduced to half, then the field will be reduced to half. That means X by 2 is the answer. Because otherwise if you do the length double, then X by 4 will come. Since R remain constant, so N by L, this ratio remain constant, and as a result if current is half, then magnetic field will be half. the de Broglie wavelength of the alpha particle and a neutron are same, then velocity of alpha particle and neutron. Okay. De Broglie wavelength of alpha particle is equal to de Broglie wavelength of the neutron. So the wavelength of an alpha particle and a neutron are same. Then velocity ratio that you have to find out. See, lambda equal to h by p. So if this is same, then we can say momentum of alpha particle equal to momentum of neutron. Then from this we can write it is m alpha into v alpha equal to m neutron into v neutron. From this we have to compare that velocity of alpha by velocity of neutron equal to m neutron by m alpha. Now, if I consider that proton and the neutron are almost of same mass, then neutron mass is m, then alpha particle mass will be 4m. So neutron's velocity will be greater than alpha particle's velocity. So option B is correct. Because alpha is 2He4, means 4 nucleons are there. So 4m, and in neutron only m. The retarding potential for photoelectrons emitted when potassium having work function 0.3 electron volt is illuminated by light of wavelength 3300 angstrom. See, this one is easy. EVS, that stopping potential you have to find out, is Hc by lambda. Lambda is given minus work function, that is also given 0.3 electron volt. 3 electron volt unit. So this one you have to divide this one by E. Minus 90, such that it will come in electron volt unit. Then put the value of lambda in meter, then you can calculate Ds. Next question is also very easy. You have to calculate the mass defect and then multiply with the C square and finally convert it to mega electron volt. Mass of the atomic mass of 2He, mass of 2He4 is given in atomic mass unit. Mass of 1H2 is also given. Then you have to find the difference of the mass, that is the mass defect. Then mass defect multiplied by C square will give you binding energy. Then this binding energy, this energy you have to calculate, and then convert it will come in joule and then convert it to MeV. Or you can directly multiply with 931 to convert it into MeV. Because one atomic mass unit, 1 U mass, if it is converted completely to energy, it will produce nearly 931 mega electron volt. Okay. Now, Next question 52. Define difference in working of an amplifier and step up transformer. See, in case of transformer, power remain constant. Amplifier can increase the power also. But this question is not in the syllabus because there is a part of the power amplifier in CE configuration of the transistor. So in that case, power is amplified. Next one is the dominated waves associated with the radiation emitted from a black body which is at a temperature of 2.4 K belongs to. Stephan's constant is given. Wavelength short means temperature is very high. 2.7 K is on the very high temperature. See, you have to use the Wien's displacement law. That is lambda proportional to 1 by T. So lambda equal to B by T. When B is that constant given, T is 2.7 K. And then the wavelength will come, and you have to remember for that the range of the electromagnetic waves. Which range is produced ultraviolet, which range is produced infrared, and all this range. Just write the formula lambda equal to B by T, where T is in Kelvin. B by T. Just put the B and T in the formula to calculate lambda and check in which wavelength range it is coming. (54) Gravitational force, buoyant force, gravitational force, thrust, gravitational force, friction. So option is none of this. The next one is also theoretical. To increase both the resolving power and magnifying power of a telescope, both focal length and aperture of the objective lens has to be increased. Next question 56. Two plane mirrors are placed perpendicular to each other. A ray strikes one mirror and then reflection falls on the after reflection falls on the other mirror. The ray after reflection from the second mirror will be. These are parallel to each other, and you can prove this actually. I will do a converse proof. That means I will consider one light ray is falling here, then it is reflected and then reflects from here. And I consider that the incident ray AB and the emergent ray CB, these two are parallel to each other. Means I am doing the converse proof. Okay. So in the question it is said that mirrors are perpendicular to each other and after reflection rays will be parallel. That the answer is actually parallel to each other. So I consider that the rays after reflection are parallel to the incident ray. Then what is the angle between the mirrors? That I will calculate. See. These two are parallel. Now I can draw a normal here. So this is I1, this is also I1. Then I also consider another normal. It will be I2, it will be I2. Now can I write that 2I1 plus 2I2, that is equal to 180 degree, that is sum of the co-interiors angle of a parallel lines on the same sides of the transversal. These two co-interior angle sum will be always 180 degree if these two lines are parallel. Then I1 plus I2 I can get, that is equal to 90. Extend these two normals. I1 plus I2, that is 90. So the remaining angle of this quadrilateral will be 90. Now this is normal, so this angle 90, this is 90, so fourth angle must be 90, because sum of the four angles of a quadrilateral is 360 degree. So if three angles each of 90, then fourth angle must be 90, means the mirrors are perpendicular to each other. So parallel light rays implies that mirrors are perpendicular. So mirrors perpendicular. Next, a clear sheet of Polaroid is placed on the top of similar sheet so that their axis makes an angle sin inverse 3 by 5 with each other. The ratio of the intensity of the emergent light to that unpolarized incident light. If I consider I1 by I2, then it is coming cos square theta from Miller's law. I1 by I2, that is coming cos square theta. I1 by I0. I0 is unpolarized, I1 is polarized. Okay. Then you have to find the value of cos square theta in this case. So in the problem it is saying that theta equal to sin inverse of 3 by 5. So I can write sin theta equal to 3 by 5. Sin theta 3 by 5 means cos theta will be 4 by 5. Just substitute. Oh, there is a mistake. See, in the first Polaroid, this one, this is I0. After going through this Polaroid, the intensity half, that is I0 by 2. Then there is a cross Polaroid at an angle theta. Okay, then after that it is I0 by 2 cos square theta. So we have to measure actually this one. Okay, so this one, so this we have to measure. That is, this one is I1. So I1 by I0, that will be I0 by 2 cos square theta divided by I0. That is half cos square theta. Cos square theta is 16 by 25, so it will be 8 by 25. 8 by 25. After going through the first Polaroid, it will be I0 by 2. Then going through the second Polaroid, which is crossed. Then it will follow the Miller's law and it will be I0 by 2 cos square theta. Then you have to find the ratio of that I1 to I0. Next two questions are not in the syllabus. Then question number 60. In a nuclear reactor, 0.01 mg of fissile material is totally converted into energy in 1 second. The power of the reactor in megawatt. See, mass difference is, mass is given. This mass is completely converted to energy. So multiply with c square to find the corresponding energy and then divided by 1 second. So it will be in watt. Then convert it to megawatt. Mass is given in milligram. So first you have to convert it into kg, then multiply with c square, then it will be in joule. Joule per 1 second means what? Then convert to megawatt. .01 milligram. Milligram to gram 10 to the power minus 3. Then another 10 to the power minus 3 means 10 to the power minus 6. This is converted to kg. Then multiply with the speed of light to the power 8. This one will be in joule by 1 second. So that is the power coming in the unit watt. Okay. Then finally you have to convert it into megawatt. So it is 0.01 into 10 to the power minus 6 into 3 into 10 to the power 8 whole square. Next question. In an LCR circuit, the capacitance is changed from C to 2C. The resonance frequency remains unchanged. Omega square equal to 1 by root NC. So product of L into C must be same. So if C is 2C, then L should be L by 2. Next question. Dimensional formula of spring constant. It is not depending on length. So mt to the power minus 2. That is option C. Next question. See, two diodes, germanium and silicon, they are connected parallel and both are in forward bias. Both are in forward bias because the battery is DC. Now, when current flows in the circuit, current flows means if one diode can conduct, then current will flow in the circuit. Not necessary that both the diodes should conduct. Okay. So, when first diode, the germanium diode will get the 0.3 volt, then the first diode will conduct, germanium diode will conduct. But silicon diode at that moment will not conduct. Then we can say that 12 volt equal to voltage across germanium plus voltage across X and ground, that is 10 kilo ohm. Then voltage across 10 kilo ohm will be 12 minus voltage across germanium diode, that is 12 minus 0.3, that is 11.7. Because when germanium diode will just start to conduct, silicon diode is still cut off, because silicon diode requires 0.7 volt. So germanium diode conducts, silicon diode is cut off. So voltage across voltage of the battery is divided into the voltage across germanium diode plus voltage across 10 kilo ohm resistor. So from that it will be 12 minus 0.3, that is 11.7. Okay. And can you tell me, when both the diode conducts, then what is the voltage across 10 kilo ohm? When both the diode conducts, then what is the voltage across 10 kilo ohm? When both the diode, write down the question, when both the diode just conducts, then what is the voltage across 10 kilo ohm? It is not 11, it is 11.3, because see, germanium and silicon both conducts, means germanium should get 0.3 volt and silicon should get 0.7 volts. So when silicon will get 0.7 volt, the voltage across germanium is also 0.7, not 0.3, because silicon and germanium diode are connected in parallel. So 12 minus 0.7, that is 11.3 volt. Parallel means voltage cannot differ. So for both the diodes to conduct at 0.3, silicon will not conduct. But when silicon diode has a voltage of 0.7, then it will conduct. Not only that, germanium also start to conduct. But since they are in parallel, voltage across both of them are 0.7. So 12 minus 0.7, that is 11.3 will be the answer in that case. Next, 64, a half kg ball moves in a circle of 0.4 meter radius at a velocity of 4 meter per second, its centripetal acceleration. Calculate. There is no use of that half kg because centripetal acceleration is d square by r. So 16 by 0.4. So it will be 40 meter per second square. Okay. Question number 65. A solid ball of volume P is dropped in a viscous liquid. It experiences a viscous force F. If the solid ball of volume 8V is dropped in the same fluid, then the viscous force acting on it. See, F equal to 6 pi eta RT. That is from Stokes law. Where this V is the terminal velocity, not the volume. I write T suffix. Okay. We know that terminal velocity is directly proportional to r square, radius square. Vt equal to 2 by 9 2 r square by 9 eta into g into rho minus sigma. So from that we know that Vt is directly proportional to r square. So I can write F is directly proportional to r cube now, because r here is 1 r square. Now r cube, volume is also directly proportional to r cube, so we can write V is directly proportional to the volume. Okay. V is directly proportional to the volume. So if V is increased to 8V, then calculate. See, I think this one is the correct way to solve this formula, because if you consider the terminal velocity constant, that means you are neglecting that terminal velocity depends on r, because Vt, that is equal to 2 by 9 eta r square g into rho minus sigma. Okay, and viscous force is 6 pi eta RT, that is coming from Stokes law, and this is the terminal velocity. Terminal velocity depends on r. Remaining factors are constant. So in that case, if there is a r into Vt, then there is a r cube term coming. Remaining terms are constant. So F proportional to r cube, volume also proportional to r cube. So it is coming that F proportional to volume. F proportional to volume. So if volume becomes 8V, then force should be 8V. Because nowhere it is mentioned that terminal velocity is taken constant. If terminal velocity is taken constant, In that case, the answer will be 2F. Then, the 66 transverse waves of same frequency are generated in two steel wires A and B. The diameter of A is twice that of B, and the tension in A is half that of B. The ratio of the velocities of waves in A and B is, you can use the formula T V equal to root over of T by M, where T is tension, M is mass per unit length. Calculate. Some data are missing. Transverse waves of same frequency are generated in two steel wires A and B. Ratio of the velocities V1 by V2 equal to root over of T1 by M1 divided by root over of T2 by M2. That is root over of T1 by T2 into M2 by M1. M2 or M1 means the mass per unit length. Root over of T1 by T2 mass M1 suppose by length M2 by length L1 to M1. M1 means L1 by M2. This one, then we can write this one is root over of T1 by T2 into L1 by L2 into M1 M2. Okay, so still means density is same, so mass equal to density into density rho into volume. Volume means L1 into area of cross section, that is pi 2 square. L1 into pi r 2 square is the volume. For second one, M2 rho into L2 into pi r1. This one is 1. This one is M2 by L2 and L1 L1 by M1. Okay, so it will be M2. So M2 will be L2 into pi R2 square, and this one will be L1 into pi R1 square. Okay. Now this L1 cancels, L2 cancels, pi, rho, all this cancels. Okay. Then tension is given. Tension of A is twice that of tension in B. So T1 is 2T, T2 is T. Then the diameter of tension in A is half that of B. Okay. If it is T, it is 2T. And diameter of A is twice that of the diameter of B. So radius is also doubled. So diameter of A, that is 2R, there is R, that's square. So it will be V1 by V2, that is coming 1 by 2 root 2. So 1 is to 2 root 2 is the answer. See, V equal to root over of T by M. So we can write V1 equal to root over of T by small m1 and V2 equal to root over of T2 by small m2, where m1 and m2 are the mass per unit length. Now this one will be root over of T1 by T2 into m2 by m1. Now T1 by T2. Now m2 means capital M2 by N2, mass per unit length. M1 means capital M1 by L1, so it will be L1 by M1. Okay. Now it will be T1 by T2, then L1 by L2, then M2. M2 is rho into length of the wire. Length of the wire means cylinder, so it will be L2 into pi R square. Length of the mass of the wire 1 will be rho into L1 into pi into R1 square. So from this L2, L1, all this will cancel, rho pi will cancel, and T1 by T2 ratio is given. That T1 is T, then T2 will be 2T, and R2 and diameter's ratio is given. So diameter ratio given means radius ratio and diameter ratio same. So R2 is R, R1 will be 2R. Then using the formula of the Carnot engine, you have to find out the work done. That is easy. Eta equal to 1 minus T2 by T1, and eta can be written as W by Q1. Q1 is given, find W. Eta 1 minus T2 by T1, then it is W by Q1. Okay. H product will remain constant. So when the tube is replaced by a tube half diameter, means radius will be half, then accordingly H will be doubled, such that product RH will remain constant. Diameter half means radius also half. So to keep the product RH constant, H should be 2H. Achha, next one, a small drop of oil spreads over water surface, because water surface have a contractile, free surface have a contractile nature, and that's why it spreads. So the correct option is surface tension. Water has higher surface tension. The materials for the construction of electromagnet should be high permeability. High permeability. See, the aeroplane has to go from this point A to that point B, and suppose wind is blowing from this side, then speed of the aeroplane is this one. Then due to wind speed is given u, and wind speed is perpendicular to the speed of the aeroplane. Now due to wind, the aeroplane will be drifted along this direction. That means aeroplane initially has to start in this way, such that its velocity's one component will help him to cross, and another component will balance this u such that it is not drifted. So in that case, draw this u here, take this angle to be theta, then this one will be v cos theta, this one will be v sin theta, and aeroplane crosses the distance is L. A to B, this distance is L. So time taken by the aeroplane T1 equal to L by V cos theta. Okay, time taken will be L by V cos theta. Next time, when it is coming here, again straight, again the same situation arises. Same situation, because now with this velocity again u is perpendicular, so it should be drifted along this direction. So it has to start with a certain angle, same angle, such that it will move. So the same time will be twice. So it will be 2, total time t will be 2t1. 2t1, that is 2L by V cos theta. Now you have to replace cos theta. From this equation you can find the value of cos theta. That u is equal to V sin theta. That means for balancing the horizontal speed of the air, that a component of velocity of the aeroplane is used, that is u equal to d sin theta. From that find the value of cos theta and substitute here. So it is u square equal to v square sin square theta, means u square equal to v square minus v square cos square theta. Okay, because sin square theta is 1 minus cos square theta, so we write that. So now we can write v square cos square theta equal to v square minus u square, and then v cos theta equal to root over of v square minus u square. Substitute directly, it will be 2l by root over of v square minus u square. That's it.
So what is the velocity of the plane going at an angle?
Yes, again.
The velocity of the plane, you're resolving it into components.
Yes, because it is saying that it is going directly from A to B. Now, if it starts directly and wind is perpendicular, then the aeroplane cannot go directly. Aeroplane will be shifted with this resultant velocity, so it will reach somewhere here. But it is said that it is going to A to B directly, so that's why I use that relative velocity. This is similar to the swimmer problem. Stream is flowing, swimmer trying to cross the river directly. Then 74. Two shells are fired from a cannon with same speed at an angle alpha and beta respectively with the horizontal. The time interval between the shots is t. They collide in mid-air q. Which of the following condition must be satisfied for their collision? Alpha greater than beta, that is not essential. Cos of alpha t equal to cos of beta into t minus t, that is also not essential. Any relation between alpha, beta and t is not essential, because for the collision, point of contact must be same. For after a certain time, they must reach the same position. That is in no option. That is why none of this is correct. The next one, paraffin have relative permittivity, that K is given 2.1 and refractive index of the paraffin is given, then relative permeability of paraffin is mu r equal to 1, then you have to find the refractive index. V equal to 1 by root over of mu epsilon. C equal to 1 by root over of mu naught epsilon naught. Mu refractive index E means C by V. That means root over of mu by mu naught into epsilon by epsilon naught. Then calculate. Power of 2.13 हो जाएगा. So this one mu by mu naught, that is given relative permeability. This one is relative permittivity, that is, then calculate. Okay. Next, a particle of mass m is moving in a circular path of radius r under the influence of centripetal force F equal to minus c r square, the total energy of the particle. See, F is given minus c by r square. F means mv square by r equal to minus c by r square. M into v square by r is the acceleration. C minus c by r. Energy means just multiply both sides by half. C by 2r. Just a minute. If this one has an inherent r cap, this one should have been inherent r cap. Correct option is B, not A. Kinetic energy cannot be negative. Kinetic energy cannot be negative. See, attractive force will find minus c by r square. So if you write the force in the vector form, it should be like this. Okay. Now, in that form, if you write the mass into centripetal acceleration. Mass centripetal acceleration is minus v square by r cap. Then r cap cancels. And all this will cancel, and this should be positive because kinetic energy cannot be negative.
But in question it is written the total energy.
Total energy or kinetic energy? Oh, then first calculate kinetic energy, then calculate potential energy, and then add. First, we calculate the kinetic energy, this one, then calculate the potential energy and add, or you can also write the total energy is negative because it is in a inverse square field. Then answer will be A, total energy will be negative. For that, potential energy is also required. Potential energy you can calculate through this, that is FDR. From this you can calculate the potential energy and then add kinetic energy and potential energy, then total energy E will become negative, that is minus C by 2. It is same as that of the atomic structure. Hydrogen atom, kinetic energy and potential energy if you calculate, you will find that total energy will be negative of kinetic energy, because potential energy will be twice the kinetic energy and negative. Because if you calculate the potential energy from this infinity to R, then you will get minus of C by R. Okay, minus of C by R. This can be written as minus of 2 times C by 2R. Then this is the potential energy, this is the kinetic energy. If you add these two, you will get total energy minus C by 2R. Then option A is correct for total energy. 77. A cyclic process is shown in the VT diagram. In the process in PT diagram will be, see, first process is A to B. A to B means is a straight line passing through the origin. So pressure remains constant, means following Charles law. So pressure constant in this diagram is first option C, AB, pressure constant. AB is a horizontal line in option 1. Then BC. BC means temperature constant. That is, temperature is constant in the part BC, in the original curve. That means isothermal. So here temperature is also constant in BC. Then next part CD, again pressure constant. So again horizontal line in PT diagram. So option A is correct. First option is correct. A sinusoidal voltage of RMS value 200 volt is connected to a diode and capacitance C in the circuit shown, so that half wave rectification occurs. The final potential difference in volt across C. You have to only calculate the peak value. Only you have to calculate the peak value. That is 200 volt is given the RMS. So peak value is coming in the output. Because in other half cycle it may be 0 because of the half wave rectifier. But in one half cycle, then what will be the value of the voltage against the capacitor? So that is only the peak value will come. So peak value will be 200 into root 2. Calculate 200 root 2. Root 2 is 1.414. It will come nearly 282 point something. Okay. Take a short break. Is fixed in the right gap. The resistivity of that wire you have to find out. See, meter bridge is balanced at 40 centimeter from left end. Means on the left side ratio is 40 by 60. On the right side left resistance is given 4 ohm. Then the right resistance say R. Then from this we can write that R equal to 6 ohm, and then R can be written as rho L by A, that is 6. L given once length 10 centimeter, diameter given 1 centimeter. From that you can calculate A and then find rho. So it will be rho equal to 6 into A. A means pi r square, that is diameter is given 1 centimeter. So it will be 0.5 whole square divided by this one is into 10 to the power minus 4. Convert it to meter square, and this one is L. L means given 10 centimeter, means 10 into 10 to the power minus 2, converted to meter. Okay. So answer is 1.5 pi into 10 to the power minus 3 ohm meter. That is option A. Okay. Next question. See, volume of a bulb of mercury thermometer is given 0 degree Celsius is V naught. The cross section of the capillary is A naught. The coefficient of linear expansion of the glass is given alpha G per degree Celsius, and cubical expansion of the mercury is given, that is Ym per degree, gamma m per degree Celsius. The mercury just fills the bulb at 0 degree Celsius. What is the length of the mercury column in capillary at T degree Celsius? See, initially we can write that V naught equal to L naught into A naught okay. V naught equal to L naught into A naught, that is length of the mercury column initially it will be L naught. Okay, A naught is the area of cross section and V naught is the volume. Then the cubical expansion occurs, and as a result mercury just fills the bulb at 0 degree Celsius. Then length of the mercury column in the capillary tube at T degree Celsius. Then finally we can write it is Vt, it will be Ld into At. Okay. Then you have to find Lt from this. Lt means if you divide this 2 by the, then we can write Vt by V naught. This is equal to Lt by L naught into At by A naught. Then substitute Vt equal to V naught into 1 plus gamma t.
Coefficient of area expansion with H is 2H.
Volume of the bulk of the market. Oh, you have to calculate through that formula. Gamma real equal to gamma apparent plus gamma container. With that formula it is because whenever you will start hitting, initially the container will expand, so the level of the mercury will drop. Then it will start rising again. Okay, with this question I will calculate and then I will. Real expansion, apparent expansion are required. Otherwise you cannot expand the answer. In a compound microscope, image between objective and eyepiece may be given, may be real, inverted and magnified. Then for hydrogen atom and electron in nth Bohr orbit, the ratio of the radius of the orbit to its de Broglie wavelength. Okay. Lambda equal to, we know, h by mv. Then divide both sides by r. Then it will be lambda by r equal to h by mvr. Now we know that mvr is nh by 2 pi. So it will be lambda by r equal to h divided by nh by 2 pi. So h cancels. So lambda by r will become 2 pi by n. And then the answer is n by 2 pi. Because r by lambda ratio is required. So answer is n by 2 pi. Then question number 84. See, question number 84. Let us consider the light is falling here. Then angle of incidence is this one, and this is the angle of refraction. Okay. Now, due to, since this is mu, this is 1 air, so light is traveling from denser to rarer. Now in this case, if there is no such difference of medium, the light ray will travel along this path, then it is the deviation angle, delta. Okay, so we can write delta equal to r minus I. Now, tell me, if we increase I, then R will increase, because if you increase this I, this light ray will move like this. So when the critical angle comes, then it will be horizontal. Okay. Now tell me whether increase in I and increase in R occurs at the same rate or not. Their rate of increase are equal or not? See, if rate of increase are equal, that means when I is increased by any amount, R will be increased by same amount. That means when I becomes this one, then only it should be parallel. But that is not the case. I increases this much, and immediate within that it goes to this value. So you can find it in another method. See, if the light is falling like this, then I equal to 0, R is also 0. Then from that, I is increased up to critical angle, and within that range, R is increased from 0 to 90. So which one is increasing at a faster rate? R. I only comes from 0 to critical value, and R immediately goes from 0 to 90. So R is increasing at a faster rate than I. Now see, if you increase I, R will increase at a faster rate, means delta will increase at a faster rate. Okay, as you increase I, delta will increase at a faster rate. So only one option is there, when with angle of incidence, deviation increase at a faster rate. Option 1. Because in option 2, initially it is increasing at a faster rate, then the increasing at a slower rate. So option 1 is correct, like the accelerating graph. Second option 3 is a retarding tendency, means increases but at a slower rate. So continuously increasing at a faster rate, that only represents by option 1. No calculation, but this is conceptually rich question. Okay. Then 85. When an AC source of EMF is given, okay, nothing is required. Phase difference is given plus pi by 4. Phase difference positive means only two components is present. One is R, another is C. If it is negative and two components present, means R and L. Phase difference positive means R and C are present. And it is mentioned that only two elements present. If three elements, then you have to calculate. Next, 27 identical drops of mercury are charged simultaneously to the same potential of 10 units, assuming the drops are made to combine to form one large drop, then its potential is.
Two options is RNC, so sir, 85. Two options is RNC.
Two options same.
Has RNC.
Option A is 1 kilo ohm microfarad. Okay. Another option is also there. 1 kilo ohm, 1 microfarad. Oh, then you have to calculate. See, resistance is 1 kilo ohm in both the options. See, resistance and C, these two are present. That is confirmed. Okay. Now, two options have resistance and C combination. Then you have to find out the value of C or resistance. Now, check both the options have same resistance. So, you have to find out the value of C. That means tan phi equal to 1 by omega C, that is XC by R cos phi. Right. Cos phi I will calculate. That will be equal to XC divided by Z. Z is root over of, or tan phi, that is also possible, R square plus XC square. Or you can also write this one, tan phi equal to XC by R. Anything. Then tan 45 means 1. It will be XC by R. So XC equal to R. Then calculate. XC equal to 1 by omega C. Either of the formula you can apply. Tan phi is more easy to calculate. XC is 1 by omega C. Omega you can find 100. So R is given 1 kilo ohm. XC means 1 by omega C. Then calculate 1 by, this one is 100 C equal to 1 kilo ohm. So it is 10 microfarad. C equal to 10 microfarad. So option A is correct. For the next question, you can apply the direct formula. V prime equal to n to the power 2/3 V. Because whenever this kind of combination comes, you have to first find out the radius, and from that potential difference when you will find, it will be n to the power 2/3 into V. Now n is given 27, so n to the power 2/3 is 3 to the power 2 by 3, that is 9. So it will be 9V. (27 to the power 2/3) means 9. So it will be 9V. V is given 10, so it will be 90 unit. Next question, 87. A conducting loop, three conducting loops, each having radius r, are moving towards a region of uniform magnetic field of induction B as shown in figure 1, 2 and 3, then current in the loop is clockwise. In which loop current will be clockwise. Now, just see the options and first option A, check. The loop is going inside the magnetic field. Means number of field lines, magnetic field is inward. So number of field lines going inside will into the paper will increase. Increases means induced EMF will try to oppose this. So induced EMF will try to produce a magnetic field which will coming out of the circle. Out of the circle. Then if it is coming out of the circle, then there is a north pole. There is a south pole. So north pole is towards you. So current is in anti-clockwise. So option A is not correct. Okay. Now come to B. See what happens. It is going away. It is actually going away from the field, that is with minus A. Minus A means retardation in the opposite direction. So it from the field it is going away. So number of field lines through it which are going inside, that will decrease. So it will try to increase that. So it will send more field inside. More field lines inside. So current direction will be clock. So option 2 is correct. And option 3. Okay, oh, just a minute. These are velocity, acceleration, acceleration. Same thing. Option 3, check. Option 3, it is going at a faster rate. So same thing will happen. So velocity is also around this, but it is not constant. It is going increasing at a faster rate. So again current will be in the anti-clockwise sense. So in 1 and 3 current will be in anti-clockwise sense. And in 2 current will be in clockwise. Okay, more option. Now this acceleration ta dekhte hobe na. Acceleration of uniform field. It is slowly moving. Acha, direction of it is slowly moving. Direction is minus A. Option 1 and 3, they are confirmed that in that option 1 and 3, check, this loop is going at a constant velocity through this one going at an increasing velocity into the region of magnetic field. So in these two cases, the number of field lines going inside will increase. So induced EMF will try to send more number of field lines to the outside. Means north pole is here, south pole is here. So current should be in anti-clockwise sense. That is confirmed. I will check the B ones. It is going at a slower rate. Slower rate means velocity is slow, but still it is going into the field. Going into the field means number of field lines going inside will increase. So again induced EMF will try to send the field lines out. Okay. Because number of field lines is still increasing. First it is increasing at a constant rate. In third it is increasing at a faster rate. Now it is increasing at a slower rate. Slowly it is increasing because it is coming with retardation. Suppose velocity is slowly decreases, so it is coming with a retardation. But still number of field lines going inside, that will increase. So number of field lines going inside will increase, means induced EMF will try to send field lines outside. So that's why current is again in anti-clockwise sense. So none of the options are correct. So you can think of this question as, suppose in first one, when it is going with a constant velocity, let us consider that number of field lines are increasing number 10 per second. Now this one is in the third case it is increasing at a faster rate, means 10, 11, 12 like this, and here it is increasing, but in first 1 second suppose 10 line passes, then 9 lines, then 8, 7 like this, decreasing rate, but still number of field lines is increasing. Going inside is increasing, so induced EMF will try to send field lines outside to balance because of the Snell's law. So in all the circuits the current is flowing in anti-clockwise. Question number 88. What is the radius of the circular orbit of a stationary satellite which remains motionless with respect to the Earth? You have to calculate the radius of the geostationary satellite. See, geostationary satellite will feel the gravitational force only, and that will be Gm m by r square, where r is this r plus h. So we have to calculate this small r. Now this one can be written as F equal to m omega square small r. This is equal to Gm, but Gm can be replaced with Gr square. M by r square. Okay. Now this m will cancel. Time period can be written as 2 pi by t. So it will be 4 pi square r by t square. That is equal to Gr square by r square. So r cube is coming Gr square t square by 4 pi square. Gr square t square by 4 pi square. It's to the power 1/3. So option A is correct.